Okay, so good morning and or good afternoon, good evening, depending on where you are. So we'll get started with the first module of this LCA very short course, which is as part of this particular project that we have with NDC Transport Initiative for Asia. And it's a part of our International Transport Forum. So let's get started. And so I'll share my screen and let me do that. I think it should be okay, but let me try it once more. Yeah, screen one, share. So let me put this on a slideshow now. I think you can see my screen. So as this part of this particular project, we have worked on trying to look at how to decarbonize transport sector, especially focused on India, looking at the alternative fuel. So whenever we try to go for decarbonization, one of the things is that we need to know what is the environmental footprint. Say if you're proposing a newer alternatives, which you claim that it is greener than the existing one, the obvious question is how much green it is. And how we can like what is like how to make sure that something which is claimed to be green is actually green. So that's the basically concept of this particular life cycle assessment. And let me switch on my video as well. Okay, so I think you can see me now. So in terms of this LCA, so what we have done in this short course that we have developed as part of this project is that we have made several like modules of approximately 20 to 30 minutes each. I've tried to keep it smaller so that it becomes easier to kind of go through that. Anything bigger videos, people don't pay much attention. So it's a smaller 20 to 25 minutes video of different topics. These slides are shared with you. You have a PDF version of these slides. And this kind of information is available from different courses, including a course that I run on YouTube and through a Ministry of Education platform here in India on what is called NPTEL Swayam platform. So let's get started. So introduction to life cycle assessment. So one thing I want to caution you that the slides are some of the slides are too text heavy, and that's being done on purpose so that you can look at it as a PDF. You can go through that and can get some details. But as part of this video, I'll try to keep it the big picture overview. I'll not go into nitty-gritty detail and kind of because sometimes that gets a little bit of boring as well. So life cycle assessment. So what we are looking at, it's basically why we are looking at. So the reason why we are talking about LCA is that we are using a lot of resources. We are using a lot of resources. Population is growing up. Affluence per GDP per capita is going up. So there is a huge concern about ability of natural resources and environmental systems to support the needs and wants of global population now as well as in the future. So that's the basis of our sustainability, which was defined by Brundtland Commission, that development that meets the need of the present without compromising the ability of the future generation to meet their needs. So that was the Brundtland Commission. So but when you talk about this, that yes, you can meet the today's requirement, but also the future generation should be able to meet the requirement. So these are good, powerful concept, but abstract. As an engineer, as a scientist, as a policymaker, we need numbers. We have to work with numbers. So, and when we are talking about this, we have to incorporate this thinking in our engineering principles. So we have to incorporate sustainability in our product development, process development, systems development. And when we say sustainability, they essentially have three pillars: environment, social, economical. So all these three has to be there, and that applied in engineering design, that's always a challenge. So this is a basic IPAT equation, which you may have seen earlier too. IPAT is impact is equal to your population times population times affluence times technology. So here population is going up, affluence, GDP per capita, we want it to go up. So what is left is the technology part. So we have to work with the greener technology. So when we say greener technology, how to identify greener technology? There are some data now in next few slides. I'll not go in great detail, I'll just summarize it. So if you look at this particular, the world population is increasing at a rate of 1 to 2%. It will possibly go up to 11 billion, 10 to 11 billion. Affluence GDP growth, max was around 8%, average is 2 to 4%, depending on some countries doing better than the others. Depending on where they are in terms of development growth as well. So especially developed countries, it's very difficult. Once you are on a very top level, it's kind of difficult to add incremental 1 or 2%, as opposed to some country which is far below in the development ladder. For them to add 5%, 10% is relatively easier. So you can look at in terms of, okay, this trend continues for several decades. We have a economic output increase by 50%. In 20 years, 300% in 25 years, a factor of 10 by 50 years. So if you use IPAT equation, what you found is if you don't have any change in the technology, with the increase in population and with an increase in the affluence, the environmental impact will grow actually 10 times in 50 years. So in 50 years, the environmental situation will get worse by 10 times. So we need to reduce the impact of technology by a factor of 10 so that we can have a better living standard. We are losing a lot of energy, different forms of energy. Some fossil fuel is still the renewables are comparatively less in use. Energy usage, again, you have petroleum, natural gas, coal, renewables, in whether where they're used the most, transportation sector, industrial, residential, commercial, electric power, those are the sectors. In terms of primary energy production, China, if you look at the different color, the yellow one is your crude oil, the natural gas and coal, nuclear, hydro, other renewables. And we say that in terms of renewables, other than some European countries, it's mostly very low renewables out there. So we have to kind of improve upon renewables. Nuclear, after the Fukushima disaster, people are still kind of worried about the nuclear one because we don't know how to manage the nuclear waste that much. These are the major global producer as well as the consumption. If you look at some countries like China, produces a lot but consumes as well quite a bit. Same with US. US in fact consumes much higher, and then Canada actually produces more but consumes less. Unlike India is the opposite of that. Then we have Australia, Norway, UK, and all those countries. So there are countries which are producing a lot of fossil fuel and other energy sources. Other thing that we can, which is not that much, which does come into picture from when you look at life cycle in terms of environmental impact, the losses that and leaks that is happening in the system. So that's also making things more energy efficiency. So here fuel cell is around 60%, but the incandescent light bulb is only 5%. So you can see that human body is around 25%. So how can we increase the energy efficiency of these systems as an engineer? So that will help in terms of environmental footprint as well. So these are some examples of different device efficiency. As you can see, ranges from 4 to 90%. And transmission loss is also there. Power plant losses are there, transmission loss. So if your fuel input is 10 units, what you get in energy output at the location where you're using is only from 100, it is only 9.5 units of energy output. So that's again is a lot of concern. So you are losing a lot of energy in the transmission. So how to work on that? So those are the ones which we have to work on, making the reduce of the environmental impact. And energy consumption, fossil fuel is a problem. Combustion, nitrogen, sulfur oxide, photochemical reaction, ground level ozone. Hydropower is good, but again, the land inundation, habitat, alternative. Nuclear power, again, how to manage the nuclear waste. Uranium mining, that's a concern. Renewable, if you start using wood, widespread deforestation. Solar panels are good, but they are energy intensive, use of heavy metals and creation of metal waste. So how to manage that? So we use variety of material, and we try to use, when we're trying to use this variety of material with increase in the population, with increase in the affluence, we are using more and more. As we are trying to use more and more, we are producing lots and lots of waste. So the question comes is, rather than using this more, of course, we have to use, because we have 11 billion people, we have to build houses for them, we have to provide food for them, we provide energy, water, take care of the wastewater from them. So we have to we have to grow. That's not an option that we cannot stop growing as an economy overall, globally, also from a individual country level too. But can we grow in an environmental friendly way? Now, when I say can we grow in an environmental friendly way, how to define what is environmental friendly? So that's where this LCA comes into picture. So as I mentioned earlier, we are using a lot of material, and in past 50 years, humans have consumed more resources than in all previous history. So in US, consumed 57% more material in the year 2000 than in 75. And now probably it is much higher too. So that's we reliance on our reliance are there on different minerals and materials out there. So we need to look at how to take the waste from that. If the waste that is coming out, how to use it back into a resource. And when we are trying to use it back into the resource, how good it is in terms of environmental footprint. So that calculation also needs to be done. So a lot of other data out there. Again, as I said earlier, don't worry too much about the text. It is essentially given for your reading. These slides are available to you as a PDF. And so in terms of video, we'll just try to keep it the snapshot. Otherwise, it will be, if I start reading these slides, that's not a proper way of doing it either. So we'll look at some of this flow of material. What is happening? We get the resource extraction, but we process the material, product design, manufacturing, use, collection, processing, and disposal. Throughout the process, you have energy, water input, you have renewable, and you have the emissions to air, water, and land. So as part of this LCA exercise, we try to capture all these things. So we do an environmental accounting exercise. So in terms of environmental accounting exercise, we are able to assess the true environmental footprint. What we have seen is that because of the huge global consumption, we are looking at that everything is being over, say 75% of the marine fisheries are now overfished. Freshwater withdrawal have doubled from 1960 to 2000. So what will happen in future? Like if the way things happen like this, it looks like we will be in a big problem. So how to avoid that problem? And what are the alternatives to what we are doing today? And how good are that alternatives from an environmental standpoint is what we kind of quantify in our LCA exercise. So here again, material management, you have natural resource use, product is being made, product life cycle is there, then you have a ecological system, you have a societal system, material being harvested, demand being fulfilled, waste material to disposal recovery, and then we try to bring this material back into the economy as much as possible. We don't want to have any waste being created at the first place. That would be awesome, isn't it? If there is no waste is created at the first place. But that will not be possible. You can go towards zero waste, but you would never have like zero waste. It's theoretically possible, but practically you will always have some waste there. So emissions, so what we do is we try to capture all these data. That's what the LCA does, capture all these data. So the data quality is very, very important from an LCA point of view. And then the kind of details about material management is a very broad concept. You look at sustainable material management is there, production, consumption, sustainable resource management, 3 Rs, 4 Rs, sound material society, zero waste, green procurement. So you hear a lot of different stuff, but there are a lot of overlapping among them as well. So the concept today says that let's try to avoid the waste being made, take the resource, use the material, make the product design, distribution, retail, purchase and use, and at the end of life, bring it back into the economy. Like they did in Japan for the recent Olympic Games, all the medals were made from resource recovered material. So that's so in terms of those, that's what we need to kind of bring it more circularity here. And there is a lot of different programs going around in the world. So similarly, water, again, a lot of water usage, water is required. So material, water, and you can also look it up. Some of this video that is the link there, you can look it up and it kind of talks about what we are using up from a point of view of where our stuff coming from, what is our consumption pattern and all that. So that's where the concept of sustainability came. But what do we mean by engineers? We're meeting society's present needs without compromising the ability of the future generation. Humans are an integral part of the natural world, so nature must be preserved. So we try to have this triple bottom line solution: good for environment, good for economics, good for society. And same thing, environmental protection, society well-being, economic prosper, 3 pillars. Again, similar stuff has been said by different literature in a different way. And on purpose, I have just mentioned all these on this slide so that it becomes easier for you to look at from different perspective, and you can appreciate the different perspective that is given to almost the same problem. It's in terms of looking at the sustainability. So engineers have created this problem to some extent by providing all these different technologies, but with a lot of emissions factors there, a lot of emissions coming out. But we are also part of the solution. We have to part of the solution as well. We have to make sure the things are done properly. So whether it's an electric vehicle or having better ventilations, better insulations, better air conditioning, all those things are needed. So these are can we come up with these solutions? The answer is yes, but not if we keep designing things in the same way. So we have to think differently. Now, when you think differently, there are traditional, what you think: function, cost, safety. Usually as an engineer, we think function, cost, and safety. But the sustainable engineering design criteria says that you also have to think about impact on people, impact on the planet. So that is also important. So how will it be made from recycled material? How much energy will it reuse? Will it be powered by battery or solar cell? So will it have parts that contain toxic metals that needs to be disposed? So these are some of the, we come up with these certain indicators, what is called the engineering design indicators, to find out which is more sustainable, and LCA helps us to quantify material use, energy use, water use, solid waste generation, emissions, toxic release, land impacts, and all that. So this sustainability and the triple bottom line, it kind of talks about that we need to think about economics, we need to think about environment, we need to think about social. When all the three meet together, it becomes sustainable. So that's how sustainability is defined. Okay, so let's quickly we'll look at some of these LCA basics. What is the concept of LCA? What are the various stages? And then you'll see more detail in the next later videos too. But in this video, we'll try to introduce what is LCA and why it needs to be done. As I said, in meeting needs of the present without compromising for the future need, we are faced with some obstacle in terms of corporate and social pressure, government and regulatory boundaries. So we lack of tools to measure our progress. So this is LCA is a systemic method for comparing products and policy from an environmental point of view. So rather than, of course, economics is important, but you just like a present cost or over the life cycle cost. What is the cost for mismanaging for polluting the environment because of the production of certain products? So when you are producing certain products, you are creating a lot of waste, and that waste is creating problem, creating sickness, creating environmental health issues. So how to prevent that? And when you're preventing it, how much benefit it really brought to that? So those things can be quantified using this. We can skip this part. So life cycle, cradle to grave, it started from raw material to all the way to the waste management, sometimes cradle to cradle as well, where you are looking at bringing it back into the economy, from moving from the linear economy to circular economy. So the goal here is to reduce resource use and emissions, and then improve the social performance, and go for cleaner products, different having advantages in the marketplace, improved platform to meet or meet business climate. So these are some of the, again, from a document which talks about 6RE, like rethink, reduce, replace, recycle, reuse, and repair. And so in environment, you have all these three: air, land, water, everything is together. Then there are this, you have the ecosystem. Then what we see is the water, energy, food, and nexus. We need water to produce energy. We need energy to produce food. We need energy to even clean water, to the drinking water system. So these are all kind of interrelated to each other. So in terms of water, not having proper water is a big problem, and health-wise. Many people, including the kids, are dying. I'm going a bit faster so that you can always go back to these slides, which is available to you. So we are using a lot of water from different sectors, like domestic irrigation, commercial, livestock, hydroelectric. We're using a lot of water. And at the same time, our groundwater resources are going down. In terms of irrigation, nearly 80%. That's a lot of water. Even for energy production, we need around 3%. domestic is only 7%. And if you look at the worldwide withdrawal, as you move from Asia towards North America, you see in Asia it's mostly agriculture, so is Latin America. But when you look at the Europe and North America, you see that it's a lot of industry which is using a lot of water as well. So, and then efficient irrigation is something which we need to work on as well. We're using a lot of water, and we're consuming a lot of water, and we are having water scarcity problem. Some depending on where you are in the world, some people uses more, some people uses less. Per capita water demand in Australia is much higher as compared to if you look at other countries like US and China. Australia being higher because they have a lot of mining activity, and the mining requires huge amount of water. So we are becoming urban. We are using a lot of water consumption. If you look at with a lot of for example, it ranges from nearly 380 liters per person per day in Buenos Aires in Argentina, where in New Delhi it is only 78 liters per person per day. So it's that you need to look at. There are some virtual water. Whenever you are wasting food, you're wasting water. So 1 kilo of coffee has 20 to 20,000 liters of water. So those are quite important. These are like water footprint. So all these calculations, and food waste is water waste, as I mentioned. So food loss is there. So water is being used for energy and other purposes as well. So energy and water are connected. Water and energy is, of course, connected. Water is used for energy production. Electricity consumes 20% of the water, excluding agriculture. Then people are also going for fracturing, hydraulic fracturing, to kind of generate fuel from there. So, but how good is hydraulic fracturing in terms of this environmental footprint? So those calculations can be done in terms of this LCA. So global water things are becoming tough. It's becoming serious issues in terms of water consumption as well as water availability, which is out there. So in some countries, water is a huge problem right now already. And many of these surface water bodies have disappeared over the years. So you see this Chad Lake, which is started in 1963 until 2001. You see most of the lake is gone. So per capita water affordability, water availability, which we see that of course quite a bit of amount of water is available in many countries, which are blue or dark blue. But there are issues of stressed population as well. There is a water scarce area in Africa, as also in India. We find some of these areas to be pretty much water scarce, which needs to be worked into. Okay, so in terms of these are some of the stuff from the water side. So we can, I think that's almost over for this particular video. World population going up, urban population also going up. So what I wanted to cover in this video is just to kind of an overview of why this LCA, what it does, and all that. So in the next video, we'll provide more details on how things are done on a regular basis. So thank you, and let's stop it here.